Hello everyone, this is a tech talk on SaltStack, a configuration management tool. What is configuration management? Configuration management is the process of handling changes systematically so that the system maintains its integrity over time. It executes configuration across IT resources in an automated environment. It is sometimes dubbed as IT automation. So why is configuration management important? Because it increases the efficiency, stability, and control. It provides cost reduction by having detailed knowledge of all elements and also avoids unnecessary duplication. Enhance system reliability, faster restoration of service, decrease risk, and greater levels of security. More efficient change management. We shall look into what are the types of configuration management. There are two types. One is the push configuration and pull configuration. Push configuration is where the central server contacts the nodes periodically. And in the pull configuration, nodes poll a centralized server periodically for updates. And SaltStack uses the push configuration along with Ansible, and the pull configuration is used by Puppet and Chef. So what is SaltStack? SaltStack more than configuration management also provides orchestration. So it's an open bus between the masters and minions, and execution modules that run on devices and report back to master. Also, it is a stateful application of configuration. So why SaltStack? Because it's very easy and implemented with YAML files in Python, and it's an open community project. And it because of the existence of multiple servers catering to one minion, it provides redundancy and also scalability in terms of geography. So let's look into the SaltStack architecture. Here we can see there is one master, and then there are several minions which communicate to the master. So whenever a communication takes place, there is something called a public key generated by the minion, which has to be provided to the master. So for them to be able to communicate, the key of the minion should be added to the accepted key list of the master. Once it has been done, the master gives the command configurations to the minions, and upon execution, it gives back the result the master. The Salt machine roles. So one is the master, which I said is the central server. So this controls the infrastructure and dictates policies for the servers it manages. And the minion is responsible for executing the commands and instructions sent by master and reporting on the success of jobs and providing the data about the underlying host. So the communication in the Salt system happens to the 0MQ messaging library. This is a very rapid and fast method, and when using the 0MQ, the Salt maintains a public key system for authenticating masters and minions. And if it is not possible to install the Salt minion on a node, Salt can also issue commands over SSH. So this is a simple communication where the master is providing the command states to the minions, and and upon execution it returns the state to the master. Remote execution is what Salt provides through execution modules, and execution modules are a set of functions that perform work on minions. Execution modules provide a concise mechanism for executing commands without having to shell out, and provide detailed instructions on how to complete the process. Modules allow Salt to abstract the underlying differences between the systems. The configuration management functionality of Salt can be accessed by creating repositories of configuration files. So there are different types. The first is states. The configuration management portion of Salt is primarily implemented using the state system. The state system uses the state modules, and which are distinct from the execution modules, which was described previously. However, they tend to mirror sometimes, but the state usually describes the system, what state a particular system should be in. So formulas are something which we have shown in the at a demo. These are the state of state module calls arranged with the aim of producing a certain result, and formulas can also be applied in an ad hoc manner. And these are the configuration management files that describe how a system should look once the formula has been applied. These are by default written in YAML data serialization format. So the templating allows Salt formulas and other files to be written in a more flexible manner. Templates can use the information available about minions to construct customized versions of formulas or configuration files. So how do the querying and assigning information to minion take place? The grains. Grains are pieces of information which is gathered and maintained by minion. It's primarily concerned to the underlying host. So this functionality can be leveraged for many purposes. An example of GRAIN would be the data used for targeting a specific subset of nodes and the pool of minions for remote execution. The next is pillars. In Salt, a pillar represents a key value stored that a minion can use to retrieve arbitrary assigned data. This functions as a dictionary data structure. What is a salt mine? It is an area on the master server where the results from regularly executed commands and minions can be stored. So let's compare what the advantages of Salt are over the other configuration tools in the market. So the state files can be simple YAML configuration templates or complex Python. And then they can communicate with the clients through SSH if the Salt minion daemon cannot be installed on the node. Also, it's extremely scalable because of the existence of the multiple Salt masters and the tiered architecture of the Salt master system. A few cons would be that it lacks reporting capabilities, and because it is not mature, the web user interface is not very developed compared to the competitors. These are a few companies in the industry that use SaltStack. And now that we have seen the architecture and the components of SaltStack, let's go ahead and demo it. So let's see a demonstration of SaltStack. We will be building a basic master minion configuration, and the management of our infrastructure is by running through the initial configuration on a Salt master server. So ours is a basic setup. So here this is the Salt server, which is basically the master, and then this is the minion. So we've named it minion 2, which will be is basically the client, and then these should be able to communicate with each other. So our Salt master will be the central server in which the design will be used both as a control center and also as a repository of configuration data. So the master is already configured, and let's just check if it is able to communicate with the minion. So let's see in the Salt keys, minion 2 should be added as the accepted key. So as it is added, so it should be able to communicate. So let's also confirm this with a test.ping, and let's see what result it shows. So minion 2, there is a result true, which is returned. So this means that the master is up and running. The next step is to demonstrate some of the basic Salt formulas that make use of Salt's built-in states to configure the server. So these Salt formulas reside in the Salt master in the /srv/salt. So let's go ahead and check it. So these are the two Salt formulas we have defined. One is the vim.sls and webserver.sls. These are basically YAML files which are saved as .sls on our in the Salt infrastructure. So let's see what we have defined in each. So Vim is basically saying to install Vim on the minion, and this we're just trying to check if Vim is already installed or not on the minion. The next is the web server, where we are trying to install Apache and PHP at the same time on the minion. So we want to install these packages on the minion using the central server. So we will demonstrate the concept of high state. So this is a way for Salt to dynamically determine which Salt formulas should be applied to a certain minion. So the minion here downloads and examines a top file. So what is a top file? So let's go ahead and check the top file. So the top file is where you define which all minions it applies to. So for example, star means for all the minions, and minion star means any minion that starts with the name minion. So our minion is minion 2, so the web server applies to it. So whenever a high state is executed, the minion requests the top.sls file from the master and searches for the formulas that it reaches to. So let's go ahead and execute the high state on the minion 2. we see the package vim is already installed, and since I had already run it once, even the it was successful, but it says all package was successfully already installed on it. Now the next feature we want to demonstrate, and the last one, is how the multi-master configuration works. So this allows for extra redundancy and also scalability. So this is another AWS instance which we are running, and we would want it to act as a master to the minion. So this we have installed Salt on it as a regular master, but the only difference here should be is that the public and the private key existing on the current master, that is our Salt, should match on this, because the minion can only hold one master server key. So let's go ahead and check what the key is. So this has exactly been copy pasted on the keys on this the new master that we have just created. And also a basic configuration on the minion is, on the minion conf file, is that we have to rename change it. So we have already done it. So initially master was only Salt, so we have also added Salt1 to it. Now let's go ahead and check if Salt1 is able to communicate with the minion. So in its accepted keys we already see minion2 does exist, and now let's execute a high state. So in this we have just defined a Salt formula to install Git. So as we see, the package is installed, but since I already ran it, so it says package Git is already installed and it succeeded. So that is it, and thank you so much.